So geometric mean. Algebra and the math lessons before that, you learned what generally what it means to take the mean of several numbers. What's another word for the mean? For the set of data.
The average.
Average. Okay. Now, in geometry, we have a slightly different type of geometric mean that actually gets used in certain fields, you know, out in engineering and whatnot, where this type of, and it's not really an average, kind of is, this type of mean is more appropriate and more useful, okay? So it's a little bit different. So the geometric mean, if I have two numbers, A and B, right? Maybe the two numbers are 15 and 9, okay? And you want to find the geometric mean between these two numbers, 15 and 9. In this case, it's just going to be A and B, right? That result will be just X, right? Okay? So to find that geometric mean between any two numbers, A and B, okay? So this is geometric mean, A and B, right? It is this, okay? The two numbers, what I say, 9 and 15 go here and here, and you put an X and an X here, okay? And then how do you solve something like this? What? Cross multiply, right? Do you remember when I told you what means and extremes are? Aren't these numbers the means? And these are the extremes, so it makes sense. Geometric mean, you're going to put an X and an X right there, okay? Or if they give you the actual geometric mean, whatever that number is goes there and there, okay? So you want to be careful on those. So, you know, product of the means, right? You remember this, equals what? Of extremes. Okay? So let's look at some examples of finding the geometric mean. Okay? Well, here, so the geometric mean between 4 and 9, they're claiming it's 6. Okay? So if we put the 4 and the 9 here, right? And the geometric mean, they say, is 6 and 6, right? Let's cross multiply. 6 times 6 is what? What's 4 times 9? Okay, so it works out. So 6 is the geometric mean. Here are some examples. So the geometric mean, it's not quite like the algebraic mean, right? What do you do with the algebraic mean? You add them up and do what? Divide by 2 in this case, right? So we're not quite doing that, but this does have an application out in the real world, okay? And certain financial applications as well. But anyway, so the geometric mean between 2 and 8. So I set up a proportion with my 2 and 8 here and here, and my x and x, or whatever variable I'm going to use right there and there. Cross multiply. X times x is what?
Oh, this is
Equals 16. So what do you do to both sides now? Take the square root. Geometric mean of 2 and 8 is 4. X equals 4.
Are we doing proofs of these?
Okay, how about between 6 and 24? Geometric mean. Same thing. 6 and 24 go there and there. Put your x and x there. Cross multiply. X squared is 144. Geometric mean is what? 12. So over here now, we got to think about simplest radical form, okay? So most of these you're not going to be allowed to use a decimal answer. You won't get credit for it. So geometric mean between 5 and 15, right? X squared equals 75, right? So x equals the square root of 75. What's the biggest perfect square factor of 75? 5's not a perfect square. Square root of 25 times the square root of 3, right? What's the square root of 25? 5. So the geometric mean of 5 and 15 is 5 times the square root of 3. 5 square root of 3. Okay? So that's why you learned that last lesson. And they do the check, whatever. Yeah. You got the idea there? So I want you guys right now to do these. Number 1, geometric mean between 9 and 16. You know how to set it up, okay? And I don't want any decimal answers. If you have to put something in simplest radical form, that's how I want it, okay? So I'll give you a minute to do that. Anybody get the first one? Good, x equals 12. So you did this, hopefully. 9 over x equals x over 16, right? X squared equals 144. Take the square root of both sides. X equals 12. How about the second one? You get that yet? 20, yeah. So all we do, 10 over x equals x over 40. X squared equals 400. Geometric mean is 20.
It's 20.
Isn't it? What's the square root of 400?
Yes.
Oh.
You just.
Oh, I have it.
All right.
I thought we were on the third one though.
We are now. Everybody get number 3. Lily? Ooh, you got something switched around. It's not like you had the right idea. Something got switched. We have something a little different.
Yeah. I got 32.
That's a little bit different, but no. How about 8 square roots of 2?
Tell me.
Oh, you didn't find the biggest perfect square factor. Well, let me ask you this. Okay, you got 4 times the square root of 8, right? Let's look at the square root of 8. Is that a perfect square? 4 and 2. So you got 4 times the square root of 4 times the square root of 2, right? If you continue on where you left off, right? 4 times the square root of 4 times the square root of 2. What's that square root of 4? 2. 4 times 2 is square root of 2. But if you take the biggest perfect square first, you don't have to go through all that, right? Well, let's set it up then. So it will be 8 over x equals x over 16, right? So we get x squared equals 128. Let me get, were you using your calculator dividing 128 by perfect squares? Yeah. And what was the first number you tried to divide it by? 25, and then you worked your way up or down? Well, you didn't go up far enough then. Anybody know the biggest perfect square factor of 128?
64.
64
What? Okay, so
times the square root of 2.
look, but 64 is in a.
Yeah, it is. 8 times 8. What's the square root of 64?
8.
So 8 square roots of 2. See how if you get the biggest one,
Hey, so
Liberty. You're better off? Okay. All right, now before we get to this next section here, let me do this. I want to give you a note. So now we're going to apply this in its correct original geometric derivation. So before we go to the note page, listen. If I have, pay attention, I'm not really going to go over this too much. If I have a right triangle, guys, and I draw an altitude from that right angle to the hypotenuse. You know altitudes are always perpendicular to the side, right? So it'll look like this. So I got a right triangle, that's perpendicular. Do I have 2 more right triangles in here? Okay. Might all of these triangles be similar, by the way?
Yep.
They would all be similar, right? Yep. So, like, a couple of them share an angle, right? They've all got right angles, don't they? Congruent right angles. So we can say that all 3 of those triangles are similar by what? Angle, right? So if all 3 of them are similar, what can you tell me about all their corresponding side lengths? They are in proportion. Hey, what does the geometric mean? What is that?
Proportion.
That's the proportion that we get from those right triangles. Okay? So I want to give you 3 cases instead of trying to figure out like which triangle similar, what corresponding sides go with what. There's 3 cases that you get, and usually you have to memorize this, but by tomorrow I'll probably let you keep a copy of these 3 cases while you take the test. Makes my stomach hurt, but I'll consider doing that. But let's go to the notes page here, and we'll see exactly where geometric mean comes from. Okay, so it comes from similar right triangles, but that's the rundown I gave you. But here are the shortcuts, right? So geometric mean in right triangles. Okay? So we have three cases, okay? And really the second two are kind of the same case, just you'll see what I mean in a minute. But anyway, here's the first case. Let me draw a picture here. So I'm going to draw a right triangle, okay? And I'm going to draw an altitude going to the hypotenuse of that right triangle. So like I mentioned before, that gave you three similar right triangles, didn't it? And all their corresponding sides will be in what? Proportion, okay? Let me label some segments in here, okay? Let me label the altitude here, in this first case, X, okay? And then this smaller segment here, I'm going to call that A, and I'm going to call that B, okay? In this situation, the first case, this altitude is the geometric mean between these two measurements here and here, okay? That altitude, whatever its length is, that number, is the geometric mean between segment A and segment B in this case, okay? So in other words, in this case, right? Does that look like geometric mean that we just did?
Yeah, what happened to B? Where did we go?
Oh, I'm sorry. I meant to put a B here. Well, excellently. I'll put it in. I got it. It'll be all right. That's a B. Okay? Now, some kids like to shortcut. You can do this, right? X times X is X squared, right? You can do that, like if you're able to skip a step in your head, right? I don't recommend it at this stage in your development, okay? Okay, so that's the first case. Whatever the length of this altitude is a geometric mean between those two. So, like if you have a problem like this, they'll have that'll be a 5 and that'll be a 7, and they'll say, what's the altitude length? And you'll do that, right? But be careful. They might give you that the altitude is, say, 8, and ask you, well, what's the measure of this side? So if that's 8, we're not going to put X and X here. We're going to put 8 and 8, right? And the X will go somewhere else in there. That makes sense? Yeah, it will. Okay, that's the first case. Here's the second case. Draw this real sloppy right triangle like we did before, okay? All right, so now instead of putting my X on that altitude, I'm going to put it over here on this long leg, okay? Now pay close attention. Here's where the change comes, okay? You see this leg here closest to where my X is? See this one, not this one here closest to it, right? I'm going to call that A, all right? And be very careful here. This one's not going to be B now. Now, in this case, this whole thing is B. You with me? So if we're dealing with this side of that right triangle, we're going to talk about this little segment down here below that's closest to it. Not this one over here, this one. And this whole thing. And then, once I've relabeled it, it's the same as this. A over X equals X over B. So in other words, whatever this segment length is, that's the geometric mean now between that length of this segment closest to it and the whole thing. All right? So now case 3, I call it case 3, but maybe you're guessing I'm just going to switch over to this side, and it'll be the same case just on the other side, but I'll put it out here anyway. So we'll draw the right triangle again. Altitude. Okay. Now I'm going to put my X here. So now all I'm going to do is just switch where my A is. I got to move over to the segment closest to it here. See that? Okay. So I'm just going to put my A here. And B will still be this whole thing. All right. You see how it's kind of the same case, just to the other side of the triangle? Or the same case if I flip the triangle around, I guess, whatever, right? So again, now that I've relabeled it, this stays the same. So whatever this segment is here that I put the X on is a geometric mean between the length of this segment here closest to it, that one, right, and the whole thing. Okay? So we got the one up here where the altitude is a geometric mean between these two segments separately, right? This segment over here is the geometric mean between this one closest to it and that whole thing. And then it's the same if I go to the other side. Geometric mean between this one closest to it. You get the idea now? So, I mean, you know this now, you're just going to have numbers to plug into this once you see a problem like this, okay? You're usually going to say, what, oh, which case am I dealing with? I'll just put the numbers in, okay? So let's go back.
So,
Yeah, I couldn't hear you. Okay, here, what do you say?
Speak up, Melanie.
with the basic, you can still do that.
Division?
Yes.
Well, this is division, isn't it?
Oh my God, never mind.
We will cross multiply, yeah. All right, let's go back and look at some examples. Where was I?
8, 1, 43.
So, yeah, so let's look at this first example here. So we have, this looks like the geometric mean set up in right triangles, right? We got a right triangle with an altitude drawn to the hypotenuse. It's perpendicular, okay? So let's find x, y, and z. Okay? Now to find x, which of those three cases was it? 1, 2, or 3? Huh?
3.
It was 3. Or 2 if you flip it around, right? Remember, 2 and 3 are really kind of the same, right? So x is the geometric mean between what two numbers, guys? 4 and, careful. Yeah, right, we got 13, okay? Now they skip to this thing. I'm just going to, so do this. X is a geometric mean, right? I'm going to put it here and here. And what two numbers go in the other slots?
13, 4.
4 and 13, right? And so they did where they started out, like, see what I mean? They cross multiplied, right? Okay? And we don't need the plus or minus, right? You know, square roots plus or minus, because we're going to deal with segment lengths in geometry, okay? So, x squared equals 52, square root of 52 in simplest radical form. So our x is 2 square root of 13.
Why do we use 9?
9 for what? Oh, because look at case 2 and 3. Look how I labeled B. It's the whole thing.
You use 9, 13.
It's the whole thing. We'll use it in a minute, right? Now let's go over to, well, they're going to do Z now, okay? Isn't Z really just kind of the same case here as X? But now, instead of 4 and 13, what are we going to use? What segment down here is closest to Z?
9,
The 9 and what?
13.
Okay? So if I do this, Z and Z, and we're going to use 9 and 13. See? Same case, just flipped around, okay? Then we cross multiply, we get x squared is 117, right? Biggest perfect square factor, 117 is 9 times 13, square root of 9 is 3, so, okay? That's why you got to get good at this stuff, okay? Now, I think what you were asking, Mr. Piper, maybe is when we're going to use these separately. How about when we find y? Because isn't that the first case? Where this is now the geometric mean between these two separately, right? So now what, okay, so y, if it's a geometric mean, we'll start it out so it's not confusing, goes here and here, and then what goes in the other two slots? Now it's your 4 and 9, because that's the first case. And then you cross multiply and all that business. Okay? Do I need to do this second example? You think you kind of get it? Like if you had the three cases in front of you, you could see it, you can kind of do these, right? I wish we would get along enough
Well,
for
it's
this
the
to
same
turn in
thing.
your memory, huh? Because you won't have that on the actual regions. They don't give you that. What?
It's the same thing, right? Just different triangle.
Yeah.
Okay.
This one's a little bit different. Let's just take a look at this last one. So now, see, this segment here is a geometric mean, right? But they didn't give you a variable. They gave you a number, didn't they? That number's still going to go here, right? Because whatever the geometric mean segment is, that goes there and there, right? So just to find out what goes now in these two slots. X and, you see, that's what I meant. You don't, sometimes you'll just be tempted to always put the X in those two spots, right? That it's whatever the geometric mean is in your diagram. that make sense? It may be X, it might be some other number, okay? All right, let's go to the next page. Another example. All right, it's kind of the same, right? Where you're not going to have necessarily the variable in 2 spots. So what I want you guys to do now on this one, on your own, is set up and solve proportions for X, Y, and Z. You should be able to get them like, do one here, and then one there, okay? So we're going to take a minute and crank through those. So there and there. And what numbers go in the slots?
6 and 30.
Yeah, because 6 and 30, right? So you get x squared equals 360. X equals, what's the biggest perfect square root? The perfect square of 360,
36.
right? You might be thinking, I don't know, it's a big number. Well, 180 is not a perfect square.
No,
Yeah, I thought,
Why did I write 360?
good question.
you had
180. I was thinking like what?
How about 180? Well, okay, now it's not so obvious. I was thinking of another problem. I'm
36.
always thinking of like 2 or 3 problems ahead. There's another one. Biggest perfect square of that is what?
36.
We all agree it's 36 times what?
Oh yeah, 4.
Really?
5 maybe.
5. So x equals 6 square roots of 5. Okay? Who got y? Get. How many got 12? All right. We didn't have to really simplify that, right? So now y is this first case between these 6 and 24, right? So 6 over y equals y over 24, right? So y squared is 144. And simply enough that y equals 12. And did anyone get z? Joey?
12 to the square root of 5.
2 to the square, what'd you get, Piper?
Same thing.
It's not 2 to the square root of 5.
Times the square root of 5.
Yeah, let me just say, I want you to write correctly and accurately, because that's the whole purpose of that, right? If you say 12 to the square root of 5, this is what you said, just to be clear. And I'm not making funny, I want to make sure everyone knows it. 12 to the square root of 5. That's what you said, where it's up in the exponent, right? Okay. Be accurate, clear, and distinct. How many got 12 square root of 5 for Z? A couple of you. Is it the simplest radical form getting you all watered up? We'll get better at those. So that would be 24, the segment closest to it, over Z equals Z over 30, right? So we get Z squared equals 720. Well, maybe then I got to get my calculator out and all that, but wait, 720, maybe we can think of it as 72 times 10, right? What's the biggest perfect square factor of 72? Well, actually, there is a bigger one.
36. 36.
Yeah, but maybe 72 is not the right way, because there's a bigger perfect square factor of 720. What is it? 144, isn't it? Times what?
Probably
Square root of 144 times the square root of 5, right? So Z, I miswrote. Because I did take the square root to get that line. So Z is 12 square roots of 5. Okay? Starting to get the hang of these? Let's,
We missed 6.
what am I missing? Okay, just for time's sake, let's move down to number 6. It's a slightly different look, okay? So notice the X here is not in one of the geometric mean places, and the triangle's kind of upside down. So let's see if we can kind of get this set up right. So everyone take a minute, solve for X, Y, and Z in number 6. Pretty sure we're going to need the length of this whole side, guys. What is this? What is this length?
on the whole side.
That's X plus 3. Okay? All right, take it from there. So we're using the 9, right, to get that our X, because it's the only thing else that has a number. So we got to use that case. right? You guys are clear. I can't find my x by using this, the case that uses this segment, because that's another variable. I can't find my x with the case that uses this side over here, because that's another variable, right? So I have to get my x by using this side over here, which has a number, right? And so if we go to this case, this is the geometric mean, which goes there and there, right? Between what, guys? What two things? 3, this segment, and the whole thing. You see it now? And the whole thing. Well, you know you can't just use x because the case needs that whole side, right? Which is x plus 3. So we get 3 times x plus 3 equals 81. Plus 9 equals 81, right? 3x equals 72. Divide by 3. So we get 24. Plus, wait, 62 plus.
Well, I just
Oh, okay. All right, we want to find y. Can we use this fact now in the diagram?
Yes.
We kind of have to, don't we?
Yes.
So, yeah, okay. So that's 24.
Plus 3.
But if we want to go after the y, guys, what's the whole segment up here? That's right. 24 plus 3, 27. See how we did that? Okay.
Yeah, from there.
I do. All right. Well,
Do the last read this question.
Oh, just got to record the.
but a lot of them are homework problem set, so we don't have to do them all here.
We'll get it.
Well, so guys, going after Z, which case is it?
The
Look back at your
first
homework.
one.
The first case, isn't it? What's that? Yes, exactly right. That's the one. That's the only one that's the geometric mean between these two segments separately. Okay.
Yeah, this was,
So I'll just put Z and Z here. Get started, right? And it's 3 and 24. Anybody got it? Other than Joey? What you got, Erica? You did? Okay, but square root of 8 still has a perfect square root. Yeah, that's an equivalent answer, but not simplest, right? So you didn't find the biggest perfect square in your original number. The original number is what, 72, I'm guessing? There's a bigger perfect square. That's why I always say try to divide out, try to top down. What'd you get, Olivia?
I got 600 square root of 2.
About 6 square roots of 2. Anybody else? Yeah, Jordan, okay. So we got Z squared equals 72. Z equals square root of 36 times the square root of 2. And that's just 6 square roots of 2. Okay? Hang of this? Bless you. All right, let's look at, so 1, 2, 3. So starting with Regis question 6. You guys all see that, your problem set for this one? Okay? So they're going to be just like pretty much what we're going to do here in a second, okay? So let's go to the first one. Okay? So let's read this over. Now listen, when you read this, it says altitude, right? Altitudes are always what to their sides?
Perpendicular.
Perpendicular, right? So know that. So that means that, and below, and also that. So that means this, doesn't it? Right triangle. And that being perpendicular means this. Just so now it looks like what we've been doing, right? Without those right angles, we can't apply these 3 cases. Okay? There we go. Let's get it labeled up. BD is 4. AD is X minus 6. And CD is X. Well, which case is this, guys, if we're going after CD, or the length of CD? Well, from what we're given, which case is this? First, second, or third?
First.
First, isn't it?
Yep.
4 is a geometric mean between these two guys, isn't it?
Yep.
So what's our setup?
4.
Geometric mean goes here and here.
X minus 6 over 4 plus 4 over 8.
All right. Now, I would say when you cross multiply this, do it so that all your x's are on the left-hand side. Because we're not really going to want negative x's here, okay? Give me a second. You're going to have to remember some of your algebra here. Well, hopefully we've gotten this far at least. We got at least that far? What do I do now? So x times x, sweet God, it's not 2x. It's x squared equals 16. Who knows what we do now from algebra?
Combine like terms.
There are no like terms to combine. What like terms are you thinking to combine? X squared and x? Are they like terms?
Well, that X is.
They are not like terms. They have different exponents.
You can't use negative 6x.
Well, let's think about y. Remember, if you have an equation with an x squared and a linear x term, is that what we have? What does it have to equal before you can solve it? 0. Whenever there's an x squared and an x, it's got to equal 0 before you can solve it, right? Does it equal 0? How do we make that happen? Well, say it the way yeah, we can't just move it, right? We've got to subtract it from both sides. So what's that leave us with? Minus 16. Now it equals 0. It's starting to look familiar. We did one of these not too long ago. What do we do? What do we have to do? It starts with an F. Keep it clean. Oh, yeah. Factor it. Let's get halfway done. Halfway done. I know some of you have learned to memorize certain plus, minus, plus, minus. God, I don't know how you're going to remember that. It's not a thing like you can remember, right? Remember, think of it this way. The two numbers that go here and here, what do they have to multiply to? False. Negative 16. And at the same time, they have to add to what? Negative 6. If you think of it that way, you don't have to worry about memorizing this chart or whatever. I mean, it's helpful at the moment, right? But you can understand that's not something you're going to carry with you 20 years from now, right? So what are those two numbers? Plus 2 minus 8, she says. Let's see. We can check. What is 2 times negative 8? Good. Now, does it add? What is 2 minus 8? Perfect. See how you don't, right? If you think of it that way, you don't have to remember the rules of plus, minus, plus. All right. What do we do with these two factors now? Set them each equal to 0, right? Because the rule is if two things, if A times B equals 0, then either A equals 0 or B equals 0, right? Well, so then either x plus 2 equals 0 or x minus 8 equals 0. What do we get over here for x? X equals negative 2, or, it's not and, it's or, because a variable can only take on one value at a time, right? It's never with an and. Or x equals what? Okay, so we're talking about a segment length. What does that mean we need to do here? What do we need to do? Because we're in geometry talking about the length of a part of the triangle. Which one of those does not make sense? Yeah, right, negative 2 centimeters, what does that mean, right? So in this case, we disregard the negative. And if this is a written part, like question, you would have to show where you disregarded the negative answer. You lose points, okay? That's why I'm showing it to you here. So the answer is what? X equals 8. Is that what they asked us, though? CD. Okay, well, that is our X. Be careful. What if they had said to find AD? We'd have to subtract, all right? Or maybe we would have started out putting our X over here, right? But if you didn't, okay? So, 8. Let's move on to this next one. Start to look familiar? Now, they're asking this a little bit backwards now, right? It's another one where they're asking kind of like the converse of it. What is it asking? In other words, what makes that an altitude, right? Because we just learned this today, that if that's the altitude in the right triangle, then all these cases are true, right? Now they're saying, all right, what number can we apply to one of those cases to make it true? Does that make sense? We've done a bunch of these. They always ask the converse of stuff. So take a minute, think of that. I mean, the setup's going to be the same, right? So basically, we're looking for AC. So I'm going to put an X here. Is this like our first, second, or third case, guys? Or first or combination 2 and 3? Second or third, whichever one, right? So that means we need something a little more than just the length of these 2 segments. What do we need?
DC.
The whole, all right, there we go. Now we're getting it. You guys are catching on. What is that? 10. And you see all those answers there? Simplest radical form. That should be simple now. What's the equation? Go ahead. Hmm? Yeah, you do. This is the case 3. Well, I'll give you a second.
No.
So, Lily, what goes here and here? X, yeah, good. What goes in the other 2 slots? 4 and what? 4 and 10. There we go. Hey, everybody got it yet? What'd you get? He says 2 squared to 10. How many agree? Yeah, that's right. So x squared equals 40. So x equals square root of 4. Well, what's the biggest perfect square factor of 40? 4 times the square root of 10, right? So you've got to know simplest radical form. We're going to be good at it. Got? All right, let's take a look at number 3. We got that? So that's an altitude, so this is going to be one of our cases almost directly. So kg is 9, and IG is 12. The length of IM. Oh, I. We might have to combine a couple things. Yes, sir. Sure.
Yeah.
If we ultimately want to find the length of this segment over here, we're missing something. What is it that we're missing? This segment here. So maybe we need another variable. Y? Let's put a y in here. So if we can figure out what y is, I think we can then use that number to go get our x. Okay. Give you a second. All right, well, so what's our setup then to find y? What? Right, just to be clear, that whatever that segment length is goes there and there, right? So then it's y over 12 equals 12 over 9. Right? Don't just automatically put whatever the variable is here and here. That's whatever the geometric mean is in those 2 spots. Okay? So we should get, what does y equal? 16? So let's just put that here. Now we can go back and use that to find x, can't we?
Yeah.
But we're going to need something x here, right? What do we need? This whole thing, which is what? There we go. Now it's straight out of the handbook, isn't it?
Yeah.
Yeah. What do I have? Oh, I don't. Okay. So I'm going to do 16 over x equals x over 25. Is that right, what I got there? Everybody agree? Yeah. Okay. You just got to know the case. And like I said, I'll probably let you have that on the test tomorrow. This is so new. Right? So, square it equals, that's 400, right? Everybody get 20 for X? This isn't so bad now, right?
It's
It's starting to go better.
see in the beginning.
Well, it's always the case with any.
No, like I mean, like the beginning of the problem, it's like second.
Oh, okay. Well, you're getting a look at all the different possibilities where they could ask it, right? So you're not going to be surprised. Well, you might be, but you'll be less likely to be surprised. All right, pick number 4. So I got a triangle T. That's an altitude, so we know that's a right angle. Perpendicular. So let's use H. UT is 12. And RT, the whole thing here is 42. So they're kind of asking like the converse reverse again, aren't they? Well, that will be part of it. Yes, we will do that. We will need to do that, definitely, right? Well, look how they're asking it.
We didn't get any numbers, so.
Wait, hang on. Look how they're asking it, though. Which value of H will make triangle RT a right triangle with that as a right angle? They're just asking you to figure out the geometric mean here so that it becomes one of our cases. So which case does it look like we're looking at? The first one, right? Where this is the geometric mean between 12 and, what do we do, Lily? What's 42 minus 12? 30. Now, come on, right? We got it from here? What's our equation?
We're finding H, right?
Yep, there's what value of H right there. What's our equation?
30 over 8 equals 8.
There you go. So H squared equals 3. That's the one I was thinking about earlier, isn't it? Yeah. That's the one I was thinking about earlier. I wrote instead of 180. I got to stop thinking ahead so much. What's the biggest perfect square factor of 360?
36.
How about 36? It works out nicely like that, right? So H equals square root of 36 times the square root of what? 10. So what's H equal? 6 square root of 10. There you go.
Yep, got it.
We got one more. And that's it. Read it over. Label. Triangle. L1 is an altitude, so that tells us again we got that. And came with 16. This might be a little bit guess and check. One.
This is very hard.
It's going to be a little guess. Sky blue. Oh. So what? Like, okay. So I think what you're going to have to do is whatever they give you here, set up the proportion and see if it's true.
It's 3.
Right? You know how to check and see if a proportion is true.
Mr. Dustin.
Yeah.
We don't have to do anything. Only one adds up to 16.
Only one adds up, so 13 and 6 does not add to 16.
So it's 3. Number genius.
It's choice 3.
Yep.
So the fact that these add to that 16 means you got a right triangle there?
Oh, not. Oh, it's not doing the bottom. I see.
Well, let's check your 3. Let's check it correctly.
Yeah.
If KL is 11, that's this, and KN is 7, what would be the proportion we check here? This is geometric mean between the one closest to it and the whole thing.
And
So we need to see if, wouldn't that 11 go here and here? Right? And the 7 and 16? And we just need to check if that's actually true. Is it? What's 7 times 16? All right, we know 11 times 11 is 121.
that's one chance.
Equals not 112. You see what I mean? That's the guess and check you got to do. Okay? Everybody think they know what it is? Okay, let's check 2 then. So 2. Let me get rid of these guys. So for 2, if LM 12, right? And NM is 9. Let's see if that works. What would be the ratio to, or the proportion to check? Right? Oh, let's just put it in lowest terms. What's 9, 12 in lowest terms?
1/3.
What about 12/16?
6/8 or
Divide them by 4.
4/4.
Divide them by 4.
2/4.
3 over, right, wait a minute. It should work out, right?
Yeah.
Is it? Let's make sure we label it right. Let's see. LM 12. Where'd I go wrong, guys? NM is 9. That's 16. So 9 over 12 equals 12 over the whole thing. 9 divided by 3. No. Okay. That's not 1/3. I went wrong by listening to this character.
Me?
You, big boy. Isn't that 3/4? Yeah.
It's not like 1/3.
Okay. It looks a lot like 1/3, you say. All right. Okay, well, there you have it.